speaker for this morning is Dr. Henry Gholz, who's a program manager in the Division of Environmental Biology at the National Science Foundation, and he's held that position since 2000. After a distinguished career as a professor of forest ecology at the University of Florida for the prior 22 years. While at NSF, Henry has managed the Long-Term Ecological Research, or LTER, program, and NCEAS for a decade. He's also co-directed the Ecosystem Studies program since 2000 and manages the new Macrosystems Biology program, which is aimed at supporting neon-scale research. Henry has also previously served as an International Forestry Advisor to the U.S. Agency for International Development and as a Program Officer for Competitive Ecosystems Grants at the USDA. So join me in welcoming Henry, and we'll hear what NSF is looking at in regards to climate change.
Well, thank you, Lynn, and all that introduction just meant that I'm a qualified federal bureaucrat. I appreciate the invitation to be here from the organizing committee and the support of the Nevada EPSCoR office and the NSF EPSCoR office for enabling that, especially under the fiscal constraints that, not surprisingly, I'll allude to and address a little bit this morning. As often happens, as I was putting together this talk with the topic of stakeholders and research, particularly focused at NSF, and as you'll see as I go along, it's a little interesting take on partnerships. Related issues kept coming up that threatened to derail me or push me down certain paths, but there were some that were very important in terms of sort of what's going on in Washington in a more general context. And some of the interactions among agencies and so on that I thought I would include here after all. So this is a revised set of the topics that I'm going to cover, perhaps covering a little bit more, talking a little bit more about the context for federal support than as usual in the NSF outreach talk. Some opportunities at NSF for support and climate change and related research. That'll be part of the good news, bad news at the end. I'm going to talk about positioning yourself for getting support at NSF and also in the larger interagency context to a lesser extent. I'm going to talk a little bit about some recent changes, about some things that I think you ought to be keep in mind when you're looking at NSF for support. And then in some of the changes that have happened and implications that there are for future funding in these areas. And then, as I said, I'll conclude with some bad news, good news, and hopefully we'll have plenty of time for discussion. Well, there was a recent Brookings Institute report that basically highlighted the larger societal context for what we're talking about here. And the last couple of talks have really highlighted it on a regional and more local basis. At the largest scale, which is the Brookings focus, they were talking about using words like unsettled, crisis, gridlock, dysfunctional. This just doesn't apply to Washington, D.C. I'm sure you know it's much more broader than that. The report didn't have, for some reason in it, and I would add to it, that the Earth's environment and ecology are clearly out of whack as well, which is why we're all here today and why we both fund, in my case, and you conduct the kind of research that we do. For example, the rate of CO2 increases in the atmosphere is higher now than ever in the evolutionary history of humans. And the implications for that are very profound. Well, despite this, the growing recognition, and Pat highlighted this very well, the recognition of this state out there, particularly of the environment and ecology being out of whack, support for research across the board is in a a steep state of decline. As you're all very painfully aware, I think you're all from state-supported institutes of higher education, or at least currently they're state-supported. There was a report by the American Council on Education that, to borrow its title, it says state support is, quote, a race to the bottom. And it projected that within 20 years, some large number of institutions, universities and colleges across the country would be down to the zero level of state appropriated dollars. Well, the graph that's on this slide shows declines from an interval of 2003 to 2012 across the federal government in support for research and development. One thing that you can see is that there are major declines in environment and natural resources. The natural resources are included in that subheading called environment. Agriculture is way down, and even for probably the first time since the 50s perhaps, human health support and space science support is down. The only major increases on this diagram are in the field of energy, which I guess shouldn't be too surprising. A lot of that's on the development side rather than there is research on there too, but a lot of it's on the development side. And in general science, and I actually don't know what that category is, although NSF is the agency that collects these statistics, I should know. But I don't know, but I'm pretty sure that climate change research is not in that category. Well, as I think you well appreciate, even way out here in the disconnected West, right, that the dust hasn't settled on the 2013 budget, while the battle lines are already being drawn by, for the 2014 budget. So, where are we and where could we be? Where could we still easily be? Or we might be going? I'm not sure. If I knew, I said to somebody earlier on a break, if I knew where the federal budget was going, I wouldn't be standing up here talking with you. I'd be somehow figuring out how to cash in on that wonderful knowledge and insight. But nevertheless, what we do know is that there was a great increase in support for this diagram, by the way, is from AAAS, and this is federal non-defense R&D. And before I go any farther, I should note the footnote here down at the bottom of the diagram that defense research and development is $90 million. This is FY12. About $90 million a year. I'm sorry, billions of dollars a year. That's a mistake. And so that's larger than all the rest of the federal R&D put together. And I'll come back to this in a minute. But throughout the vertical axis doesn't start at zero, so that's one thing to notice here. So basically, since since World War II, the increase has been monotonic, all the way up through the last years of the Clinton administration, during which NIH, which accounts for about 25% of this, went through a doubling. And actually, for the first couple of years of the Obama administration, the Bush administration at the end of the Clinton year, NSF was on a doubling track, which would have taken 7 years. We got 2 years, and then that stopped. And you can see through the Bush administration, through the current administration, there's been a gradually eroding support. Except in the year of 2009, that was the ARA, or the stimulus year, which I think where all of our budgets went up suddenly by 50%. That was a shocking year for all of us. We can basically ignore that. The likelihood of that happening again is virtually nil. But the blue line here on the right side, the upper line, as it turns out, was the 2011 Budget Control Act. And if we actually let things go at that point, with all of the various clauses that were in that, things wouldn't look too bad. The red line is what happens, what was projected to happen, and is in fact happening with under sequestration, with the 5.2% across-the-board cuts. The gray, very low line here is what would happen if the defense R&D was taken off the table. And even a couple of weeks ago, that was a definite possibility. And you can see that would have, because defense R&D accounts for so much of the federal pool that would really hammer all the other agencies. Well, then just 2 days ago on Monday, this was finally clarified, at least for FY13, by Bill H.R. 933, which approved the FY13 budget for the rest of the year. This includes some restoration of some of the sequestration funds to selected agencies, and it turns out NSF is one of those. So this year, as it turns out, for the rest of the year, that the NSF budget will be minus 2% over FY12, which of course is considerably better than minus 5.2. So, considering the other potential outcomes, we don't feel so bad. However, I'm not going to cheer about a cut, and I don't think you ought to, and I'll come back to the ramifications of this in a minute. But particularly because this wasn't an across-the-board increase of federal agencies. So most of our sister mission agencies, as you might call them, everything but NSF, are suffering at least that 5.2% cut, which affects all of you out there very much. So now we can look, what's going to happen to the future, and I know you all look forward, like I do, to the wonderfully stimulating and exciting debates that are going to occur over the FY14 budget. When you think you've heard just enough, you haven't heard anything, basically. But that's at least 3 or 4 months down the road, so take a breather here. But what are the consequences for society, and especially for science, then, of this kind of budget management and the scenarios for the future, which certainly don't look great? Well, first, polls continue to show that society still places a large amount of trust in science and in scientists. Hopefully that will continue. Second, it's ironic that when faced with such major uncertainties, as I outlined earlier with the Brookings report, the demands and the fact that, as a result of that, the demands and the expectations for science are so high, funding, of course, is in decline. But in any case, or perhaps because funding is in decline, the science that you do needs to be very solid. And because the problems in the field are so urgent, as we've just heard so poignantly, we need to make some major advances in the fields and in our understanding of what I would just call the global ecology for now. And not just the usual and more marginal contributions to our collective understanding that we generally do on a daily basis. But of course, the problem is with declining resources, competition is stronger, and so the institutions and the PIs that they hire, meaning you out there, need to be aggressive and you need to be creative in your pursuit of those resources. Consider for a minute, in addition to, again, what we just heard about water, some of the issues that require fundamental information and insights that we really don't have, that we're facing right now. All of the ramifications and implications of new energy development and its use, climate change and its myriad consequences, water being among them. And of course, this is not unrelated, as we heard in the first talk, to energy development. Rapid urbanization in the U.S. as well as all over the world, and we've just passed that point where now half of the world's population lives in cities. And in a more local example, I guess you could say, the multifaceted challenges of managing the public investment in lands and in water in the western United States. So where does NSF fit into this milieu, aside from the EPSCoR program, which I think you all well know? Well, NSF is the only agency that in the federal government that doesn't have a mission, or I should say perhaps that its mission is to support fundamental research, which by definition is not mission-oriented. Call it what you will. But a little known fact that is that at NSF right now, I would say, and I'll try to convince you of this, that the funding opportunities for environmental research or global ecology or climate change or whatever you want to call it under this big umbrella have never been greater. well, how can this be? How can you have declining budgets and still have more opportunities? Well, I think that what this reflects is that programs are evolving, new programs are developing, and there are major programs, major changes in programs that are possible. So again, that means that institutions have to be aware and institutions have to be involved, and I'll talk to you how that happens. In order to keep abreast of these changes and to make sure that you're well positioned to compete at the high level that's required. So NSF is a small agency compared with all the other agencies. This is, again, looking at research and development across the federal government. You can see that NSF accounts for 3% of the pie. DoD, not surprisingly, if you're looking for the real money out there, is just over half of the federal R&D. NIH is about another quarter, and then the other agencies split it up, the peanuts up amongst us. Well, when you look at the impacts of the budgets out there at the university situation, where you all are, you see a very different kind of picture. So NSF funds out of non-defense and non-human health. So we call that environmental biology or call it whatever. Again, these are NSF statistics. NSF provides about 60% of that across the board. Well, I've already showed you that between defense and NIH, that's 3/4 of the R&D budget, so it's a little bit of cheating here, but there's actually another good and very important reason for this. If you look at the R&RA, which is the big part of the pot, the pie in this diagram, it's 80% of the NSF budget. You add in their education and human resources, which just because of past politics is a separate appropriations. So you have those two together, so you're talking about 93%. And then you add in the major research equipment and facilities construction, which builds ships, builds ground-based telescopes, particle accelerators, and NEON, which was just mentioned a minute ago. I'll come back to. You're up to 96% of the NSF budget. So all of this money goes right up. This is taxpayer money appropriated from Congress, and for every dollar, 96 cents of that goes out. So that's a very efficient use of taxpayer money. It basically says NSF has a 4% indirect cost. It's really a function of the fact that we don't do anything in-house. NSF is a pretty boring place when you go there because when you visit, it's just got all the doors closed because everybody's in panels and that's it. So we really just give out your taxpayer money to you at a pretty efficient rate. We don't manage labs. We don't have facilities that we manage our own. We don't have NSF scientists that are conducting research like all of the other agencies do. So the problem with that, of course, is that if you get a budget cut, then we pass all those savings, if you will, however you want to look at it, those cuts on to you. So every dollar that NSF budget gets cut, 96 cents of that gets passed on to you. So you're NSF's main stakeholders, if you will. Okay, so if you're NSF's main stakeholders, then your main stakeholders are your research partners and your collaborators. I just wanted to say a few notes about that I thought might be useful or interesting in this context. NSF review, even though a lot of people think it's this way, and if you get declined, you sure feel this way, is not a lottery. No awards are not preferentially given to well-established, better-known PIs. So when you write a research proposal at NSF, you should have collaborators on there, but they should be the ones that are necessary and required absolutely to get the work done, including yourself. Not the biggest names that you can find. You also need to choose collaborators that match the solicitation of the program that you're applying to, because it may call for particular kinds of expertise. And maybe that you're going to have to add a collaborator, because what you're responding to in the solicitation, or what your ideas are that you're articulating your proposal, You simply aren't qualified to do all the work for and answer all the questions and address all the technologies that you're going to use by yourself. So that's the basis on which you want to select your collaborators. Another note that's I think, relatively underappreciated, and it has some nuances I'd be willing to talk about later, is that federal scientists can be included on NSF proposals. They can be leads on sub-awards to your proposal. They can be consultants, or they can appear as PIs or co-PIs through courtesy or adjunct appointments that they may have at your university or at somebody else's university. This is not generally an NSF decision. Okay? We won't give a grant to another federal agency, but we can support other federal scientists. We're not going to pay their salaries, we're not going to buy major equipment for their labs, but there are a lot of ways to do this, and we see that happening quite aggressively in certain other agencies. It's generally an issue of either the universities, which have to approve these people to be on grants that they're submitting, or it's up to the other agencies themselves who may not want to have their scientists diverted from their missions to work on some esoteric NSF proposal, so to speak. But in any case, it's important for you to be ready and to anticipate when you're thinking about proposals and putting proposals together of new programs, whether it's to NSF or other agencies. No agency is going to announce in advance that it's going to put X million in a brand new program. We don't lead the community in a way like that. But many agencies, in fact, I would say most agencies, in fact, perhaps all agencies besides NSF, I'll come back to this, commission reports in various ways that lead the way or provide hints of what may be coming. And so I'm going to talk a little bit about some examples from my own experience. I sit on several interagency working groups for the U.S. Global Change Research Program. One of the most active ones, one I'll highlight here, is the Interagency Carbon Cycle Working Group. So there's about 10 agencies involved in this, and we meet every 2 or 3 weeks. And we talk about what things we might want to do in the area of carbon cycle research. NSF is generally there not to join in, but to make sure that we're always talking about fundamental research and so on as a piece of this. But nevertheless, we are there, and the Carbon Cycle Group has a very organized community out there. And some of you hopefully are part of this. But this is an example of how you can become involved. There's a program called the North American Carbon Program, which is the community's manifestation of organizing around carbon cycle research. They've produced now, since 2000, they've produced 2 decadal, the most recent one in 2011, strategic plans for carbon cycle research, carbon cycle science, in this case in North America. If you look, which you should, at the NASA ROSES solicitation, which is their new, it comes out every year, but it says what they're going to fund over this next 6 months or 3 months or a year or whatever. I can't remember if the ROSES comes out annually or biannually. But if you look in there, you'll see the fingerprints of this North American Carbon Program strategic plan all over it. And you'll also see that DOE, NOAA, and USDA, maybe some others, maybe are also putting money in there. So they'll be listed in that NASA ROSES solicitation. So it's come directly out of that report. The DOE's Next Generation Ecosystem Experiments is an ongoing thing where DOE has commissioned a number of workshops and workshop reports to help define what that is. What they do is they bring together the community out there to help make recommendations to them about what they might want to do. The second is the National Academies National Research Council, which produces reports all the time. These are generally commissioned by agencies. And so when you look at reports that come out of the NRC, they're often thinking down the line. Well, what if they're sort of trial balloons. What if we wanted to do this? Or what if we were thinking about this? What would you think about it? Asking the national academies to render an opinion. For example, there's been a lot of key reports that have come out over recent years on climate change, not surprisingly. Also sustainability, which is showing up in more and more places now. And there's been a lot of very recent reports and workshops to the NRC on urban issues. In fact, one very recently on urban forestry. And if I think about my interagency working groups and I think about the NRC reports and so on, urban is definitely a topic that comes up more and more. I'm not giving away anything there, I'm just saying that that's what I hear. I don't think it's that surprising at a general level. In the middle here, NSF funds all kinds of workshops and things like research coordination networks and so on that produce reports and they become part of the open literature out there. However, NSF usually doesn't respond to these first two things that I've talked about here, unless there's some new money involved, and as we just talked about, there really isn't. So we don't take our programs and when they're headed down here and move them over 90 degrees because a workshop report says, gee, it would be great if NSF put all this money over this way. That doesn't happen. However, we do have internal advisory committees to all of the directorates at NSF that, in fact, do make recommendations directly to us. And we have the National Science Board, which, in fact, governs us. And if the advisory committees, but particularly if the NSB says NSF should do something, basically we take that as important. So if you look at who's on the advisory committees, who's on the National Science Board, it's community members, it's you out there. When things advance enough, and in NSF I'm talking about here, to the point where some change is required or some policy statement needs to be made, then we see things show up on the NSF website, and there's mass mailings out to your sponsored research offices and everything else. Letters from the director, and this happened, for example, if you want to know how NSF is responding to the sequestration, there's a letter out there on the NSF website from our director that explains it. And it's what you see quoted in all the newspapers and all the press releases and so on. Dear colleague letters, that's more down at the program level. So if we decided to launch a new program in environmental biology or change significantly our procedures, which we have recently, then we would put out a dear colleague letter. And of course, at the most fundamental level, if we're going to change how we're going to run a program, then we change the solicitation, and this is a legal document and so on. It's the thing that you need to read and be responsible for when you prepare proposals. So, for examples, again, I mentioned the U.S. Carbon Cycle Science Plan. This is the second one, the 2011 one on the left. The one in the middle, Accelerate Synthesis, this was a report that I commissioned from a workshop that we invited people to towards the end of the NCs, or National Center for Ecological Analysis and Synthesis years. This was about 4 years ago, which led directly to a new solicitation and the creation of sort of the Next Gen Center, the Social Economic Synthesis Center that's at University of Maryland in Annapolis. And then the red and the green books here are from 2003 and 2009. These were by an advisory committee for environmental research and education at NSF. And these pretty much set the blueprints for the biocomplexity and environment program that ran for 10 years and just sunsetted recently. So all of the directorates in NSF have some things in common. We all do things, so math and physical sciences, and in our case, biology. We have programs, we have core programs, and then we have special programs, and then we fund things like early career opportunities and fellowships and all that kind of thing. So I don't need to show you all of those because they're pretty similar, just in the different disciplines. So where I am in environmental biology, we have ecosystem programs. We have an integrated in iOS, the integrated organismal systems, in another division, which is animal behavior and physiology. We have an infrastructure division. The one thing bio does differently, and I just sort of alluded to this, is that Bio has invested heavily over the years in synthesis centers, which have working groups, postdocs, sabbatical opportunities, and so on. And so NCs that I just mentioned is one, it's the oldest one. It's been running since 1995 and sunsets this year. But there are a number of others, Succinct that I just mentioned, and others that are very active in various aspects of climate change science. I mentioned NEON earlier, and I don't think you've all been asleep over the last few years. This actually has been percolating since about 2000. But NSF is investing basically $500 million in the next 7 years over a 35-year environmental observing network that covers the United States. It actually has a lot of similarities to your stations and all up and down the transect here, but imagine this at 60 sites from Alaska to Hawaii to Puerto Rico. NEON's going to be a game changer, there's no question about it. You think, for example, of PhD students in ecology or PhD students in environmental studies will be more like PhD students in astronomy, where they may not go out in the field and collect data. They're going to be deluged with incredible amounts and flow of information for free off the NEON website. So are we ready for that in ecology? I'm a forest ecologist. I got into it so I could be outside. And to think about having grad students that don't want to or don't need to go out to do a dissertation is very interesting. So I think it is going to be a new day for ecology and environmental science. It was mentioned in the introduction that I co-manage actually with Liz Blood, who's the NEON program director, this macrosystems biology program. It's only been going, it's in its third year now. It's envisioned to go 10 years. And basically, this is priming the pump, so to speak, for ecological and environmental research done at regional to continental scale. So in anticipation, basically, of NEON. So these are, not too surprisingly, pretty large and pretty integrated, pretty complex projects. And probably are some of you in the room that have participated in that. Well, there are many other examples across the foundation that I could provide of now where, quote, climate change research is funded. Geosciences, not surprisingly, they fund oceans, earth, atmosphere, so they're big players in the environment and in climate change. The polar programs, which is housed again in GEO, they fund the Arctic and Antarctic, but if you know about or if you look closely at the earlier, some of the earlier diagrams, you can see that a lot of the climate change is happening at higher rates and greater degrees at the high latitudes. So these are very important supporters of research on the poles. Geography and spatial sciences, you'd be surprised at how much social science now funds climate change related research. Geography and spatial sciences covers a lot of the remote sensing of what I would call landscape ecology. Engineering has gotten to be an increasingly large player in the environment. So when I talk about opportunities being greater than ever, this is what I'm talking about. And although there's not new appropriated dollars for this, I think what you're seeing at NSF is that there are more programs trying to be players in the, quote, environment. Some of that's driven by some messages from the top, others just driven by the realities of the circumstances we all see out there. And so from our standpoint, from when I think about our sort of traditional DEB or ecosystem kind of PIs, I see these as new opportunities and basically as new money. But you've got to be creative in getting it. One of the things you may have seen in NSF is an acronym called SEAS. This is Science, Engineering, and Education for Sustainability. This is designed to be explicitly across NSF. So again, there's no newly appropriated dollars for SEAS, but in 2013 there are 13 solicitations under SEAS. 3 years ago there were 0. Okay? And you have to have more than one directorate involved, so engineering, geo, and bio, or something like that. So again, these are opportunities that are there that weren't there in the past, and I won't go through all 13 of these, but they range from postdoc fellowships, and I just ran a postdoc fellowship panel, to things like ocean acidification that were mentioned earlier, water sustainability and climate, coastal seas, hazards and disasters, and so on. So, where you see climate change research in here is really a challenge and up to you. Well, coming back to more practical matters, the single most important message I should leave with you about NSF proposals is the following: that you should always lead with your best ideas for moving forward the frontiers of science, and that everything else must logically follow. This is the greatest contrast between writing a proposal to NSF and writing a proposal to any other agency out there. So, in this context, I sometimes wonder, and I've talked to some people over the years, whether F-score states and PIs may face somewhat of a paradox, and it's one that's going to be shared by NEON users and other users of infrastructure that's funded separately from the science. If you think about it, the idea of investing in infrastructure is to enable science that couldn't be done otherwise. But building things is inherently a process that's designed to be low risk. So, for example, NSF isn't going to invest $500 million in NEON to have it not work. Or a telescope, or a ship. You can't build ships that are going to sink. So, likewise, when you think about states getting big F-score awards, things that are built or bought or positions that are provided should be relatively low risk. You want to see a return on that. But research that can really transform a field is rare, and therefore it's inherently a very high-risk venture. So our programs put out a lot of money to projects that sort of peter along. Some of them don't go anywhere, some of them go in different directions. And very rarely do we get the quote transformative science being done. And NSF, though, we bristle at the notion that maybe we're only funding safe science. People only send proposals to us for marginal safe science. But I think it's a challenge, and I'll throw it out here, is how you lead with your cutting edge ideas that are highly risky in the one sense, but have potentially high payoffs if they work, while you're also trying to leverage investments in infrastructure that have been built to minimize risk. Well, I talked over this with my F-score colleagues at NSF, and I think they generally agree that the idea is right, that certainly if you're writing for NSF, that you ought to lead with your best ideas. And then your facilities, including your F-score facilities and everything else, need to follow. It also means if you're being paid by F-score, that they're expecting you to be out there leading with your great ideas and hopefully going to get that strike out there in terms of your research. But it's a delicate act and a challenge, and it's going to be for NEON users of the future, and it always has been for people wanting to use LTR sites, to lead with your ideas and then let the sites and the facilities and the measurements you're going to follow going to use logically follow from that. So keep in mind that NSF is not a monolithic organization, and forget the notion that it never changes. Managing proposals and programs in NSF is a very highly dynamic enterprise. I'd be happy to talk with you more about that afterwards, but it really involves a lot of the community, and it's highly dynamic. Quality always trumps quantity. NSF has minimal rules compared with most other agencies, but there are rules, and NSF expects them to be obeyed. And so that comes back down to the tedious task of making sure you know your solicitations. Again, the specifics are in these solicitations, and it is your responsibility to know them. So just as in closing here, as an example of a recent and a pretty major change, because of the ever-increasing demand, there's numbers of proposals that have come into NSF, and the steady to eroding support, what's that meant for funding rates? As many of you experienced, painfully, funding rates have gone down tremendously. So in response to that, and in response to the burden, the additional burden on you, aside from writing a lot of proposals, that most of which don't get funded, is then we ask you to review proposals or to be on panels. It's sort of like insult and injury. So some of our directorates, in fact, 2 of the divisions in bio, my division, environmental biology, and iOS, have changed our core program solicitations from, we used to accept full proposals 2 times a year. Now we're doing pre-proposals 1 time a year. And if your pre-proposal gets accepted, then you write a full proposal. The idea is to cut way down on the number of full proposals that you, the community out there, has to write every year, and cut down on the reviewing. I'd be happy to talk about what we think about this, and I'd be happy to hear what you think about this afterwards. But it's a challenge to write pre-proposals. When you have 15 pages, you can talk about a lot of your details and nuances and things. When you've got 4 pages of text for a pre-proposal, it's a different idea. What it basically does is basically highlights what I said just a minute ago. That if you don't have your exciting ideas out there in a very strong conceptual or theoretical framework, then your pre-proposal is not going to go anywhere. So it is a challenge. Interestingly, the feedback that we've got so far, at least on the panelist side, is that they feel they can judge it's actually 5 pages, 4 pages of text in the first whole page. They can judge the pre-proposals quite well. We haven't heard any complaints on the reviewer end. What we've heard so far from you, and I'm not trying to be definitive because this is very still early in getting feedback, is that people generally seem to like writing pre-proposals and not writing full proposals. The biggest problem that we've heard, and we recognize this, we're trying to figure out what we might do about it, is going from 2 times a year opportunities to 1 time a year opportunities. And we're very cognizant of this as an issue, particularly for people on soft money and for young faculty who don't have a lot of opportunities to get grants before they're up for tenure. So we recognize this. We have a blog, and we'd like to get your feedback, and you're welcome to send your feedback to me, and I'll be happy to respond and talk about it. So in conclusion, there's good news and bad news. Bad news, or in summary I should say, really, the bad news that the pressure to secure NSF and other agency funding has increased while the budgets have not. I could say, well, the budgets have decreased here, to be realistic. Funding is harder to get. Success rates from 2000 to 2012 for our core programs like ecosystems, ecology, and hydrology and all that, but using the DEB examples, they've declined 50% since 2000. And again, then we switched to the pre-proposal. Other federal research support across the board has decreased, and state support is eroding rapidly. The good news is that across NSF, and I can't speak for other agencies, but I don't think this is the case for most other agencies because they already have their legislative missions. Across NSF, there's more potential sources for funding in this area of climate change or environmental science, or whatever you want to call it, than ever before. We have core programs that are coming on board that are more interested and open to proposals in this area. We have special programs in like macro systems and others, and centers, and NEON coming down the line. And this is a lot of money. NEON is in fact newly appropriated dollars, almost $500 million into your field. So the bottom line is that programs are adapting, and so much do. So again, thank you for enabling me to be here, and I look forward to questions now, or I'll be here through the rest of the day and through the poster sessions tonight. Thank you.
Thank you, Henry, for bringing us up to date on what's happening with NSF and sequestration. We will take 1 or 2 quick questions. Okay, then we'll move forward. Thanks again, Henry.